Hello students, welcome to online physics classes. This is the first class for class 9 where I shall discuss the basic facts regarding the chapter gravitation. Now during the discussion I do consider that you students have a clear idea regarding the two topics, motion and force, because this motion, laws of motion, force, these are the very basic fundamental ideas that you have to know, because this chapter gravitation, if you want to understand this chapter gravitation, you should have a clear idea regarding those topics: motion, laws of motion, force, etc. One more thing, while proceeding throughout the discussion of this chapter, you will get some stories, because stories are a very integrated part of this chapter. In my other classes also, I have told this many times that physics is not only some reading of some facts, it's deep observation of some phenomena and then trying to establish the logic behind those phenomena. So while reading these theories, now we are just as we are reading the theories of gravitation, we must try to think what was the reason behind, we must try to relate with them some phenomena while reading these kind of chapters, and we must try to think what observations lead to the discoveries of these kind of theories. One interesting thing I remember now, see, we are going through a pandemic due to this COVID-19 in this time. This chapter gravitation has, it's heard that this chapter, the discovery of this chapter has a deep root connection with this kind of quarantine time period. It was during the Great Plague, the pandemic of the epidemic of Great Plague. Sir Isaac Newton was sent back to his home, like many of our students are sent back to their homes from colleges. So Sir Isaac Newton was also sent back to home during the Great Plague. The time was probably around 1665 or like that, when Isaac Newton was in his late 20s or something like that. So this theory of gravitation and many other important theories of Sir Isaac Newton, like the many theories of calculus, the foundations of calculus, the some important theories of optics, those were developed by Sir Isaac Newton during his homestay during this quarantine time of the Great Plague. So we see we are getting bored during this entire pandemic situation, but Sir Isaac Newton took the time positively and so for his taking the time positively, many discoveries are here now we are getting. So with this positivity, we are starting our classes. We are starting our first discussion on gravitation. So let us start the discussion on gravitation. As I told you earlier that while reading this chapter, while going through the discussion of this chapter, we'll be getting some stories. The stories which will ultimately help us to understand the reasons behind the development of these theories. The first story starts with Sir Isaac Newton. It is said that once Sir Isaac Newton was sitting under an apple tree. All on a sudden an apple fell on the ground. This strikes into his mind. What might be the reason that the apple fell on the ground? What is the reason behind this motion? As we know that behind every motion there is a cause. Force is the cause behind every motion. So what is the force? Who is applying the force over here? And as the apple is falling, so there should be a kind of attracting force. And this earth is giving the attracting force. He extended his thought and started questioning more and more and tried to establish the logic behind many heavier motions. He observed that, as we know, the Earth as well as the other planets are evolving in a circular motion, along in some circular paths. So, while reading motion, we have known that whenever a body goes in a circular motion, two forces acts on it. One is centripetal and centrifugal. So both these forces are responsible for this motion of a body in circular path. This centripetal force is attracting the body towards the center. The centrifugal force is repulsing the body from the center. Both these balancing the motion of the body. And ultimately, this centripetal force is very much required for the circular motion of the body. Now, as these cosmological objects, these heavenly objects are revolving in a circular orbit, what might be the reason of attraction? What might be the attracting force behind these kind of motions? Because we see that he generalized this kind of concepts. If the apple is falling on the ground and the ground is attracting the apple towards it, so the earth might attract some other heavenly bodies also towards it. He started generalizing this kind of concepts and developed the great law of gravitation, which is later known to be the universal law of gravitation. He observed very deeply and came to a conclusion that every object in this universe attracts every other object with a force directed along the line of centers for the two objects, that is proportional to the product of their masses and inversely proportional to the square of the separation between the two objects. Now, he calculated this formula. How this formula comes, we are coming to later on. But let us first understand this statement. So what's the statement? Every object in this universe, he has generalized every kind of objects in this universe, that every object attracts each other with a force. We are not getting into the line of force. You will get this kind of line of force in little classes. Simply we have to understand that every object in this universe is attracting each other with a force which is proportional to the product of their masses. Means, if Fg is the gravitational force due to gravity, this gravitational force, this term was coined by Sir Isaac Newton. He discovered this force. He actually concluded that this force will be known as gravity, and while we are universalizing, we are generalizing this, it will be termed as gravitation. So gravity is a term strictly confined in the case of Earth, and gravitation refers to entire universal concept. So this force of attraction will be directly proportional to the product of mass of the bodies. Means Fg is directly proportional to m1 and m2 if m1 and m2 are the masses of two objects. And then if r or d, whatever maybe you are taking, if d is the distance between these two objects, then it will be inversely proportional to the square of the separation or distance between these two objects. So what is the universal law? That each object in this universe attracts every other object with a force directed along the line of centers of the two objects, and that is proportional to the product of their masses and inversely proportional to the square of the separation between the two objects. This G is known as universal gravitational constant, because we know here the law states about some proportionality only. F is proportional to m1 and m2, product of m1 and m2, and F is inversely proportional to d square, if d is the separation between the two bodies. So G is the constant of proportionality. The calculated value of G is 6.67 into 10 power minus 11 Newton meter per kg square. So now let us know the value of G, how it's calculated. This is the universal gravitational equation, the value of g, this g is known as the universal gravitational constant. The value of g is an extremely small numerical value. Its smallness accounts for the fact that force of gravitational attraction is only applicable for objects with larger mass. While two people will indeed exert gravitational force upon each other, these forces are too small to be noticeable. Now, as these kind of sentences have many hidden meanings in that, we can have many conclusions from this kind of sentences. Means, we know that each object, from Newton's third law of motion, that every body exerts an equal and opposite, every action has an equal and opposite reaction. It means if I am attracting you, you will also attract me. Each of us, and again if the law says that each object is attracting each other, means both objects are attracting each other. Now suppose two men is walking side by side along a road. If they are separated by a distance of 1 meter, then there should be a gravitational attraction between them. So why don't they just collide into each other? This is because this gravitational force of attraction will be applicable for greater masses, for large masses only. And the thing is, from Newton's second law of motion, we see that acceleration is inversely proportional to mass. So if mass becomes heavier, acceleration will be lesser. So this is one case, that while two people will indeed exert gravitational force upon each other, these forces are too small to be noticeable. This will be one case. Another scenario is that a common question will be arised, that if each other is giving a force on each other, then if the earth is attracting us and we are getting into the trap of this gravity, if the apple fall down because of this gravity, the apple will surely attract the earth also. Why doesn't the earth moves and the apple comes? This is because of their mass difference. The gravitational force of attractions becomes noticeable only when the masses are too large, and if the masses will be too large, sometimes this will be the acceleration will be very less. That is why if the earth is attracting the apple is also attracting earth, but due to very negligible mass of the apple compared to the mass of the earth, so the motion, the acceleration of the apple is noticed, not the acceleration of the earth. The same case applies to human beings and other objects lying on the earth also. And this universal concept also applies to the cosmological or heavenly objects. The heavier objects become the center of rotation of the orbits of the lighter planets. So the body with larger mass will be having lesser acceleration, and the body with lower masses will have more acceleration if there is a kind of motion due to the gravitational force of attraction. The next topic of this chapter is free fall, that is motion under gravity alone. Free fall means, see, we have studied motion. Motion is because of motion is something result of some application of force, and there should be an ultimately resultant force after the application of many forces. If some forces exist, there will be some motion. Now we see some jumpers are jumping from, in this cartoon clip, a jumper is jumping from an aeroplane to the ground. We see many kinds, some skydivers are jumping from planes and like that. In this case, the jumper is getting only two kinds of forces. One, the force of gravity, the force with which the earth is attracting the jumper towards itself. Only because of this, the jumper is falling down towards the earth directly. And one, the resistive force of the air. Here we will be discussing regarding the force, that is the earth is, by which the earth is pulling the heavier on the objects, and only that force of gravity is only be applicable to that condition. That kind of condition is known as free fall. The free fall is just nothing but a motion under gravity alone. It means no other forces will be acting on that particular object in that period of time. But now we observe, suppose we throw a ball up higher to the sky. What it happens, the speed of the ball gradually decreases while it goes up, and while it comes back down towards us, the velocity or the speed of the ball increases. So what is the reason behind this increases? Or we see that if someone jumps from higher up, like some aeroplanes or some thing like that, then the velocity of the jumper increases as it comes down to the earth. So what is the reason behind this kind of increase in speed? And as we know that if there is a kind of increase in speed or velocity, then there is a kind of acceleration related to it. That acceleration is known as acceleration due to gravity in case of free fall. And this acceleration due to gravity is denoted by small g. The universal gravitational constant was written by capital G, and this acceleration due to gravity is small g. What is this acceleration due to gravity? The universal gravitational constant capital G was a constant. This is also a constant, but this is constant for a given planet and depends on the planet's mass and radius. This will be a calculated value which will be different for different planets because the force of attraction of different planets will be different. These are some calculated values. So what is the acceleration due to the gravity? Acceleration due to the gravity is the acceleration produced only when the force of gravity is applying on the object. See, it is also independent of the mass of the accelerating object. The object which is getting accelerated, this g doesn't depend on the mass of that. This d depends entirely on the mass of the planet and radius of the planet on which the phenomena is going on. Calculation shows that the earth has by putting different values of this in this equation, gm by r square, where m is the mass of the planet, or in our case earth, this g is the constant of the universal gravitational constant, r is the radius of the planet. Then by calculating for this from this equation for our earth, the value of g comes to be 9.8. It means that if anyone is falling from the sky towards earth, the earth will be attracting the object with an acceleration of the motion of the body, or the object will be an accelerated motion, and the acceleration will be constant, approximately 9.8 meter per second square. And this table shows that for different planets, suppose for Mercury 3.7 meter per second square, this Venus is 8.9, Moon is 1.6. See, Moon, the gravitational attraction of Moon is very much less compared to Earth. Mars 3.7, Jupiter, Saturn, Uranus, Neptune, these are high. These don't have any solid surface also. The gravitational attraction is so high in these planets. But these planets, Mercury, Venus, Mars, these have comparatively low value of G. It means whenever if someone from a sky jumps to the surface of Mercury, the surface of Mercury, the planet Mercury, will be the motion of that body under the atmosphere of Mercury will be a constant motion with an acceleration of 3.7 meter per second square. So we have just got a new parameter g for acceleration, which is acceleration due to gravity. Now we are setting the equations of motion that we got in the earlier chapters in force and laws of motions, which is the equations of motions describing the motions of some objects. The first equation was v is equal to u plus at, s is equal to ut half at square, v square u square. So these were the velocities, the final velocity, the initial velocity, the acceleration, the time taken, the displacement. So this new kind of equations will be replacing a by g. So what will be the new type of equation of motion? V is equal to u plus gt. This g is the acceleration due to gravity. This, while solving numericals for this chapter, we have to keep in mind that this acceleration is entirely due to gravity. So we have to take the value of g as constant, and we should use the acceleration as g only. Now h, ut plus half gt square. H means the height of the object. It means whenever we are in horizontal surfaces, we are calculating distance, but in case of gravity we are always actually calculating this vertically. So why we are calculating vertically? So here we have replaced the distance with height of an object, and v square is u square. Final velocity remains same, initial velocity remains same, just a is replaced by g. The acceleration becomes acceleration due to gravity. Now, a very important difference we have to know: mass versus weight. As we have just got introduced to this acceleration due to gravity g, so now we'll have to differentiate between two very important quantities that are definitely not same, but many of us think these two quantities are same: mass and weight. Weight is never mass, mass is never weight. Mass is actually the amount of matter in an object, the amount of matter contained in an object. It means how much of matter is contained in any kind of object, that is known as mass. And what is weight? Weight is nothing but a force. Weight is a force by which the earth attracts any object towards itself. Mass is what? Mass is the amount of matter contained in an object, and weight is nothing but a force, the force by which earth pulls any object towards itself. So if mass is the amount of matter, what will be the unit of mass? Might be gram, might be kg. And what would be the unit of this weight? The unit of weight is neither gram nor kg, nothing. This is just a force. So the unit of weight is Newton. And how is this weight is calculated? As we have got that the earth attracts anything towards itself by an acceleration, constant acceleration, that is acceleration due to gravity, which is constant, 9.8. So the amount of matter contained in an object plus the amount of acceleration produced. If we product these two this mass along with this g, then only we will get weight. So mass and weight are entirely two different kind of things. Mass is the amount of matter contained in an object, and weight is the force by which earth attracts anything towards itself. So weight is numerically calculated as m into g. M is the mass of object, g is acceleration due to gravity. Suppose a body has a mass of 10 kg. Suppose a body has a mass of 10 kg, then the weight of the body will be 10 into 9.8, approximately 10, so approximately 100 Newton. So the weight of the body having 10 kg mass is 100 Newton. So we'll try to demonstrate this through an example. As we've got earlier, I showed you earlier that the moon, the value of g in moon is very less compared to the value of earth, 1.6, as the earth's one is approx 10, this is 1.6. So let's check what will be the weight of bodies on moon. A body is taken to have constant mass of 120 kgs both on earth and Mars. But this 120 into the value of g of Mars and g of Moon will be approximately 200 Newton. 120 into 1.6, which will be approximately 200 Newton. So if a mass of 120 kg will have a weight of 200 Newton on Moon, the same mass 120 kg will have a weight of 1200 Newton on Earth, because this 120 into 10, approximately 10, that is the value of G in Earth, will be 1200 Newton. So the same thing, the amount of matter is same, 120 kg, the weight of it is 200 Newton on Moon, the same mass 120 kg, the weight is 120 into 10, approx 1200 Newton on Earth. So there is a big difference on weight and mass and weight. Mass is exactly the same, 120 kilo of this body on Earth and on Moon, but weight is 200 Newton on the surface of Moon, and weight is 1200 Newton on the surface of Earth. It's also to be observed that the weight of an object on Moon is 1/6 time of the weight of an object on Earth. 1/6 time of 1200 is 120. We will be calculating this same kind of thing. Suppose this is a theory that is in your book. The comparison of a weight of a body having same mass, constant mass, the weight of a body of same mass on the surface of Moon and on the surface of Earth. Suppose the mass of Moon is Mn and its radius is Rm. If a body of mass m is placed on the surface of the Moon, then the weight of the Moon will be gmm by this. It means by this force, this is from the law of gravitation. This is the mass of Moon, gmm. This is the mass of the body, small m. This is the mm is the mass of the Moon. This is universal gravitational constant. Rm is the radius of the Moon. So the Moon is attracting the body of mass m with the force of this gmm by r square. R is the radius of the Moon, and as the body is in the surface, so the distance will be Rm square. The same body, weight of the same body on Earth's surface will be me. This is We is the gravitational force of Earth, but by which the Earth is attracting the body of mass m. This m is the mass of the body, and me is the mass of Earth. Re is the radius of the Earth. Comparing this Wm by We gives this kind of equations, which after solving and after putting the calculated value of mass of Earth, mass of Moon, radius of Earth and radius of Moon, after these simple calculations, the calculated value comes in this way, that the ratio of weight of an object on Moon to weight of an object of the same object on Earth becomes 1/6. It means weight of an object on Moon becomes 1/6 of the weight of an object on Earth. The weight of an object on the Moon is about 1/6 of its weight only on the Earth. See clearly in this from this diagram you can see that the mass was 120 kg and the value of G on Moon is 1.6. So 120 into 1.6 is around 200 Newton, and 120 into approx 10 is 200 Newton. So it's 1/6 times of the value of 200. This is 200. So the weight of an object on Moon is 1/6 time to the weight of an same object on Earth.